Hi there! In this video we are going to have a code practice. We are going to build a dashboard and host it locally. For doing that, we are going to analyze our data in a batch mode. We already did it in the previous module, so I believe you know what's going on here. We are going to simulate the batch usage of our service. We are going to continue using bank marketing data, and we will calculate reports and test suites for each batch of data. Then we are going to spin the service, which will be a monitoring dashboard, and we are going to browse all the metrics from the reports and tests in this live dashboard. Let's dive into it. First of all, I'm going to create a new file and save it in my module 6 directory. For now, we have requirements here, right? So make sure you have everything installed. And yeah, if you do not work with any text data, you can just get rid of NLTK. It's quite a huge library. And well, as I promised, let's create new file. Should be inside of module 6, and we will call it batch monitoring dashboard. Here we are going to write instructions to first load our data, then calculate reports and test suites, and we are going to calculate all the reports and test suites right there, just to simulate that we actually have a production pipeline and we get like batches of data. In the real process, you would rather have some prefect or airflow, maybe pipeline, right? And you would calculate those snapshots one by one as soon as you got new batch of data. But now, for the simplicity and for speeding things up, we are going just to implement it in Python cycle and calculate all those snapshots like in a row, right? So let's start from it. The idea is first to load the data, then calculate reports and test suites, then save it as a snapshot, then finally create a project, create the dashboard, and spin up local monitoring dashboard. So let's do one by one. And I would start from the importing of things from Evidently and scikit-learn. So there are quite a lot of libraries. This is why I just decided to paste here everything. We will need to use datetime, dataset. We are going to build both reports and test suites. This is why we import report, we import test suite, and we report column drift metric, dataset drift metric, and data drift test preset. We're also going to build a dashboard. This is why we import quite a lot of things from UI dashboard. This is counter egg, dashboard panel counter, dashboard panel plot, etc., etc. I believe it will be more convenient if I comment them when we use them. And finally, while you spin up a local monitoring dashboard, you need to specify where your workspace is, because the workspace will be used to store all your snapshots and assets like configs, etc. So we are going to use workspace and we import it from Evidently. Well, I believe that's it, and now let's start from the loading our data and specifying some global variables. I would rather start from the workspace name, project name, and project description. I'm going to reuse those variables and it will be like related to the whole script, right? This is why I prefer to create some global variable. Basically, here you can specify all global things related to your machine learning monitoring dashboard. So I would call my workspace bank data, right? Why not? It will be a local directory which will be created right there from where I'm going to run this script. Bank data, and you can specify the full path if you prefer. So my project name, let it be bank marketing batch, And the reason is that I'm going to create later online dashboard. So I mean not really online dashboard, both this dashboard and the next one will be online, but now I'm going to calculate my snapshots in a batch mode, and in the next video we are going to calculate our snapshots in the online mode, right? And this is why, to be able to distinguish between those projects, I'm going to say bank marketing batch. It will make more sense in the next video. And description, let's write something fairly simple. Test project using bank marketing data. Okay, now I'm going to load our data, bank marketing dataset. If you haven't seen our previous videos, let me quickly comment on that. We assume that you have batch production process where we receive data in batch and batch size is equal to 2000 rows. But here in example, we load the whole dataset from dataset scikit-learn so that we have the whole data all together. And in order to simulate this batch process, we assume that first 5,000 rows we used previously for model training, so we do not use it here. Then we created the reference dataset. It's the next 2,000 rows after the training, which means it's from 5,000 rows to 7,000 rows, right? And starting from 7,000 rows, we have our production simulation data, and we are going to split it into 2,000 batches, right? This is why we have variable batch size. So that's how we simulate the real production process. Of course, when you will work with your real data, you won't be able to receive the whole data set at once, only historical data, and new batches of current data you receive one by one, right? But for our experiment, that's okay. So now let's create a couple of functions, one to generate for us report and the second for generating some test suites. It will be just standard Python functions which will return reports for us. So my report will consist of two metrics. First is dataset drift metric, which calculates the number of drifted columns and share of drifted columns, and I'm going to separately calculate column drift for a target variable, which is class in our case. I also want to simulate the daily usage of our report generation, and I'm going to pass here a timestamp to associate my report with a specific time slot, right? And I'm going to create my data quality reports in a cycle where I'm going to push here I variable, which will be responsible for a day, right? And I'm going to run it several times, each time passing there different I, and it will be different days, because I'm going to use this time delta, and probably I would even do like this. So now let's run calculations and return report. Here is also an option to pass some tags and metadata to our reports. I'm not going to use it now because we are going to create only one type of reports, but I will just place this parameter here so that later, if you're going to create more sophisticated reports or maybe create different types of reports, you could use some tags to pass it to the web interface. We are going to see it in a few minutes, and maybe filtering some reports by those tags. So I'm just placing here empty list of tags, but later if you're interested you could use some tags as well. So that's it. Now let us run calculations. And actually I could pass my reference and current data there, but I already created some global variables, and what I'm going to do next, just access here my global variables and specify which batch of data I'm going to use with help of my index and batch size variable. So basically what we did here is we created a report which consists of two metrics. We added timestamp, we didn't add any tags, we ran calculations and we returned report. Let us create very similar helper function but for creation of test suite. The reason why we even need these functions is that we are going to create quite a lot of reports and test suites in a cycle mode, so it will be much easier to have such helper functions. Okay, here we are. We have both our helper functions for generation report and test suite, and our next step would be to actually build a project with the dashboard and configure what exactly we would like to include in our dashboard. I would rather also create a helper function which I will call create a project, because here I'm going to create projects, place it in my workspace and specify how I want to configure dashboard, which is the parameter, it's a part of our project. And evidently we have pretty nice interface to work with projects. It's a workspace, and basically in a workspace you can create a project, you can alter a project name and project description, you can also add reports and add test suites to the project, to the workspace, right? And manipulate with the dashboard through the project. And the logic is that the workspace is your working directory. You can think of it as a working directory, but basically this is the space where you store your projects. Each project should be related to the model or maybe several models united all together by the problem statement, and for each project you can build up a dashboard which contains different plots, right, which are panels in our case, and you can associate as many test suites and reports as you want with specific project. So the idea is that you specify each project you work with and store your reports and test suites for each project separately so that you can analyze it and build a dashboard for each of your projects. So workspace, projects inside of workspace, and all the reports, test suites, dashboard, it's all specified for each project. I believe you will understand it very, very soon in example. So I create my project. I also specify the description for my project so that I can quickly remember what it was. And I start to configure my dashboard with help of addPanels method so that I can then see my panels in the dashboard. And we are going to call addPanel method as many times as many panels, which are plots, we are going to add to our dashboard. I'm going to create like 2 panels for reports, 2 panels for tests so that you can see how it looks like. And then I believe your fantasy helps you to like update this dashboard and build something which makes sense to you. So let me start from this simple panel. And I will use dashboard panel counter. So that's basically the reason why we imported so many things from Evidently UI dashboard. Dashboard panel counter is just a counter, so basically we aggregate here some statistics or just create a very nice label, and here I'm going to just add a label without any statistics. That's it. That's how we can create a panel counter. So evidently we have different types of panels. Here we can see panel counter, and for any panel we can use a filter which helps us to filter out which reports or which tests to include in this panel, right? If you use some metadata values or tags, we can filter out specific reports with the specific tags. For instance, it can be daily reports, so it's reports which we calculate on top of daily batch of data, or it can be specific reports like drift analysis or maybe data quality analysis. Maybe we can use different reference data to calculate our reports, and in this case we can add a tag, my daily reference or my weekly reference or my experimental reference, and then build a panel by sorting the data only with this reference, right? So feel free to play around with different tags and metadata, because it lets you to collect a lot of different snapshots in the same project, right? And then play around with the panels consisted from different reports and test suites again. So yeah, let's add a couple of more panels. Now I'm going to use dashboard panel plot instead of counter, because now I want to see not the counter but time series plot. So let me add it. For each panel, in case you use dashboard panel plot, you can specify menu values. Those values will be different lines or histograms or bar on the same plot, right? Basically, here you can also specify a title, a filter, so it's very similar to what you saw in dashboard panel counter, but instead of aggregation type, you could specify the values. It can be as many as you want, so we have here a list, and here in this particular panel, I'm going to add only one value, which will be drift score for our target variable. I'm going to derive it from my report, so it will be report metric column drift metric and the column name class. I will need to specify all those informations to my panel to make sure that evidently parses your reports correctly and derives the right metric for the right column and derives the right field from this metric. Let me show you how you can specify that. So for each panel we can add parameters like metric ID. This is necessary because we need to know what metric to parse to look for the specific field. We can add some metric arguments, and for column-wise metric it makes sense to add here column name because it might be quite a lot of same metrics calculated for different columns, right? And in order to specify which column you mean here, it makes sense to add the column name here. Then field paths, because for each metric we have generally quite a lot of different statistics, and for the drift score, for instance, for drift metric we have drift score, we have the binary resolution, whether drift was detected or not, and many other fields, so I need to specify that I want to include specifically drift score to my panel. And again, this is the optional, but I want to add target class, right? And you can also specify the plot type, which, for instance, here I would like to have as a line, and size, let it be half-sized. Well, that's it. I would like to also mention that evidently we have a documentation related to how you can make such plots and what parameters there are, so not try to remember it from the video. If you need to, you can always go to documentation and see some examples with already created plots so that you can see what instructions lead to what picture. And well, I'm going to add a couple of more panels so that you can see a nice, beautiful and big dashboard. So let me continue. Now I'm going to add dataset drift. I don't really need metric arcs here because it's dataset metric. Additional way how you can specify which fields to parse from the metric is just by name. So let me add it here, but it should be full name. And again, in our documentation, you have an instruction how you can figure out what fields there are in metric. It's very easy, it can be done with help of as dictionary format of metric, or you can specify parameter fields and see the after completion after. And let me come up with some legends. And now, just to entertain you a little bit, let me change line type to bar so that we have different examples of plots. So I think that's enough, and second panel I'm going to use will be related to tests. I also imported this type of panel from the very beginning. You can see that we can specify the title here, the filter as well, and here I would like to say include test suites true, because we are going to parse test suites type of snapshots, and widget size half, right? And let me add one more for tests, and here I would like to have a detailed panel with tests. So I alter a title. That's it, we just configured our dashboard, and now let's save the project and return project from this function. Finally, let's implement our last function, which should be create demo dashboard, right, and run our dashboard to see what we have configured so far. In our create demo dashboard function, what we did, we just created workspace, right? It's right there. Also, we created project in our just created workspace. So first the workspace, then the project inside, and then we created several reports. I would say 10 reports and 10 suites, and we added all these reports and suites to our project by project ID. Basically, that's it. And if you run our create demo dashboard here in Python, we will see what actually we created. So for doing that, I first save our script. Then I believe we would need to do some debugging, but that's what we usually do. So Python and then this batch monitoring dashboard. Let's see. Oh, okay, so let's go. This is something, yeah. After we did some debugging, let's run our batch monitoring dashboard. And it should create for us quite a lot of snapshots, 20 actually, and store it into a bank data directory. Probably that's it. Let's see whether we have this directory now. Yes, here it is. So it's our workspace, and now we need to run monitoring service. We can do it with help of evidently. So basically here is the help for us. So if you write evidently -h, it will tell us that basically there are two commands here, two services, collector and UI. Collector we are going to explore in the next video, and now let's run UI because it's our dashboard UI. And here we have quite a lot of parameters. Basically there are host, port, workspace, demo projects, if you prefer to just see demo project first and then design your own project, secret, and help. I'm going to specify workspace because the default doesn't work for us really. So workspace, and our workspace is called bank data. Basically that's it. All the rest options are good with default values. So let us start it and wait until it's running. Yeah, now it's running. So we go back to the browser and we follow this address, and I can see that here is the evidently UI with the list of projects. We just created bank marketing batch, so if we open up it, you can see that there is our nice dashboard, right? So we started from the dashboard panel counter, it's here, bank marketing dataset, and then we created two panels out of our reports. First with the target drift for target class column, right? And here it is. And it should be 10 points here, like from November 5, it's today, to November 15, I guess, or 14, 15. Yeah. And the last point. I also have the bar plot here with dataset drift share, so we can see the share of drifted columns here in dataset, and you can see that it increases, which totally makes sense, right, as we accumulate more data. And we also have very nice panels for data drift tests. Here is an aggregated panel where we can see the aggregated values for failed and successful tests, so 13 successful tests and 5 failed, and we also can see that share of failed tests increases with time, which makes sense. And here we can see all tests individually, so we can navigate to each date, to each test, and see the timestamp, see the column. This column is V14, not very informative, but still. And the test is called drift per test. So green is success and red is fail. Here again, you can see that we have more red tests closer to the end of the period, right? That's how you can build up a dashboard, and also luckily we have an access to all individual reports and tests which we saved there. So if you navigate to the reports tab, we can see that there are all our reports, and we can view any of them for additional information. Like we can see here dataset drift, here it is, 17 columns, 9 drifting columns, right? And here is the plot for drift in a column class. So that's exactly matches the report structure which we created from our script, right? And we loaded 10 reports here, and you have all these 10 reports presented there. You can also download each report and then send it over to someone, right? Or just open up in browser. And we also have test suites. If you open up, you will see that here is our summary of tests, 8 successful tests, 10 failed, and all the results right there. So we can open up each individual test and see the differences between the distributions of this column here. So there are quite a lot of information, and whether you prefer to see the live update dashboard, you can go to the dashboard field, and in any time if you want to observe what exactly has happened in a particular batch of data, you can navigate to the reports and test suites and do your debugging. Well, that's all I wanted to share with you in this video, and I believe now you see that it's fairly simple to create a dashboard using Evidently. And well, this scenario works very well for batch models, where you can calculate each individual snapshots on top of your batch data, right? And then just store it in your working space directory. What if your model is deployed as an online service? Well, in the next video we are going to explore Evidently Collector service. This service allows you to send the data via post to the monitoring service and then calculate snapshots based on those data. Let's see how it works.